Welcome to the exam prep for 7534, Architecting Microsoft Azure Solutions. I'm Sydney Andrews, Cloud Applications Consultant, and also the author of the edX course, Architecting Microsoft Azure Solutions. I have a background in both Azure and XAML consulting. Today I want to review the third exam in the road to the Microsoft Certified Solutions Developer Certification for Azure Solutions Architect. This is one of 3 exams. They don't have to be taken in any specific order. And each of these exams will earn you a specialist certification. So you get a prize for your victory today if you earn a certification. And you get a big prize if you earn all 3 certifications and pass all 3 exams. So that's 4 certifications for the price of 3. That's a big deal in my book. I got 4 certifications for what I thought would be 3. Now, today we're going to go over some of the objectives for the 534 exam. And these objectives include designing around infrastructure and networking, so IaaS, securing resources, designing a storage and data access strategy, designing an advanced application, designing web apps. They're called websites and injected domain. I've left this as it is because websites is what it's called injected domains, just to keep things from being confusing. But when we talk about them in the presentation, we're going to refer to them as web apps. And finally, designing a management, monitoring, and business continuity strategy. We're going to break these objectives down to 6 main topic areas for this session. That includes infrastructure networking, security, storage and data access, advanced applications, web apps, and business continuity. Hopefully, after watching this session and studying for the exam, you're able to earn the Architecting Microsoft Azure Solutions exam or certification immediately. But as with all certification prep, even if you don't go take the certification exam today, we hope that you listen to this session and other study materials will help you learn to be a better architect of cloud solutions using Azure. Now, with this session, I'm going to be referring to 2 different portals, the existing or current management portal, manage.windowsazure.com, and a preview portal, portal.azure.com. I'm going to use both of these portals, and as somebody who's taken a certification exam in a technology that's evolving, it's expected that you become familiar with both portals. The preview portal can become the current portal at any time, and the certification exams, they tend to take time to develop questions. So we're in a transition period where there's some features only available in the preview portal, some features only available in current portal. And to be successful in Azure and earn the certifications, you probably need to be experienced with both portals. Let's start by talking about Azure infrastructure and networking. One of the big things around Azure infrastructure is understanding what the data centers are and what they mean. Azure has 19 data centers, and this number is growing. Every time I show this slide, I'm already outdated. But if you knew what time I was recording this slide, you'd probably laugh at me because you say, hey, you forgot this data center and that data center. So this number is not even important to remember at all because it's changing too much. These data centers integrate software, hardware, operations all together in one facility. Now, we have regional availability. So based upon whatever region we're in, we would have typically 2 data centers in a region. And this way, you actually 2 different buildings at a minimum for a region. If you put something in West US, there's a minimum of 2 different buildings. That number can grow at some point. That number can change a little bit. But right now, we have this concept of regions. And this is what you see in the portal, East US, West US. And within these regions, we actually facilities or data center buildings. So 16 buildings per region is typically what we see right now. Again, none of these numbers you need to know for the certification exam. This is something where I'm just giving you information because it could change. These numbers can grow easily. And as fiber infrastructure, Azure has a global footprint with fiber infrastructure connecting many different countries, many different cities. It's massive. The amount of fiber that's laid down to support Azure is astronomical. Now, when we do talk about our individual services, we tend to put them into virtual networks. And virtual networks in Azure offer us quite a few different things. One of the big things is with virtual networks is that they provide a kind of DNS service for our cloud services. So our cloud services, when they're in a virtual network, have a DNS name. So it might have xcloudservice.cloudapp.net. And that DNS resolves to the cloud service. Now, within the cloud service, we create endpoints. These endpoints route requests based upon that DNS name from the cloud service to an individual VM. The machine names themselves are just modeled explicitly. So the actual virtual machine names really don't have anything to do with the routing. They're just there for an actual name of the machine. You can change this behavior if you don't want to use the built-in cloud service load balancers. You can bring your own DNS. You can bring your own DNS server, deploy it to Azure, and use that, or use a public DNS service. The most important thing that you want to take away from this slide is around DHCP. So we have public IP addresses that are in a pool of IP addresses available to Azure. And when you create a new cloud service instance, you have a public IP address assigned to that cloud service. So that's called, well, this public IP address is virtual because it's in this pool of IP addresses available to Azure Cloud Services. So we call this a VIP. So the idea with the virtual IP address of VIP is that there's one virtual IP address for the cloud service. Now, we can create endpoints for VMs within that cloud service, and it'll route requests from that VIP to that individual virtual machine. But if we want to create a PIP or a public IP address, we can create a PIP. We can create a public IP address to route traffic directly to a single virtual machine instance. This is all the way it works in classic virtual machines infrastructure. When you get into V2 infrastructure, it changes this all on its head. It's a completely new model and completely different. But for as far as certification exams, it does refer to VIPs and PIPs directly. So you do need to be well-versed in the classic virtual machine infrastructure, classic networking. You can use an IP address with different cloud services. The way you do this is you can actually reserve a VIP. The IP address that's assigned to that cloud service, you can reserve it and use it across different cloud service instances. As far as virtual networks and services, network security groups came about as one of the, I want to say one of the last features that was added to the way classic VNets and cloud services worked. But network security groups are front and center for V2 infrastructure because network security groups kind of replaces this whole logic of endpoints and access control lists as far as V2 infrastructure. But for your certification exam, you definitely want to know the classic infrastructure and how it relates to network security groups. So a network security group is assigned to a subnet. So remember, an access control list is assigned to a virtual machine endpoint. A network security group is assigned to a subnet. Now, a virtual machine endpoint is touching one virtual machine, whereas a subnet can have as many virtual machines as you want to put in there, as long as it's within, there's enough IP addresses available. The big thing about these network security groups is it allows us to apply rules to a subnet and have these rules inherited based on each virtual machine within a subnet. So if I have a subnet with 3 database virtual machines and I want to allow requests to the correct endpoint for SQL Server, TCP endpoint, then I can do that at the subnet level. So that if I create new virtual machines, if I shut some down, start some up, if I'm using autoscale, anything like that, I don't have to make sure each individual virtual machine has an endpoint with the correct ACL rules. I implement all of my rules, what IP address ranges are allowed, what ports are allowed at the network security group level of that subnet. And all these rules are implicitly followed by each of these virtual machines within that subnet because they won't get the requests anyways. So it kind of gives me a way to manage my access at a higher level than each individual virtual machine. When we talk about compute options in Azure, we really are breaking down into 2 PaaS options and 1 infrastructure option. From an infrastructure point of view, we have virtual machines. There has a lot more management capability, but we sacrifice for control, ease of use. So it's not as easy to manage because we're doing a lot more work. It's not as agile because we're doing a lot more work. But what we get for that trade-off is tons of support for legacy applications, tons of control because we manage and we own the virtual machines. We can support far wider scenarios than any platform as a service solution. When we start talking about platforms as a service solution, the solution that is closest to virtual machines is cloud services. Cloud services gives us some control and support for legacy applications. If you need to install a driver, you can create a startup script in PowerShell and install what you need. So it gives you a level of support for legacy applications and gives you a level of control. These are actual virtual machines, so you can do interesting things. You can control endpoints and things like that. It does, however, provide more ease of management, more agility than virtual machines because we're not actually managing the actual OS, we're not managing the actual machine itself. So we're not sitting here creating new VM instances and installing the right things on the operating system as far as IIS or things like that for web roles. That's all handled for us. If a cloud service role instance goes bad, it self-heals. It creates a new instance and deploys the cloud service package or the binaries that's appropriate for us. So the big thing is a lot of this is managed for us. It gives us a ton of agility and a ton of ease of management. But that's not all. What if you want more? What if you want to be completely out of the operating system game? You don't need PowerShell scripts to install anything new. You don't want to manage anything. You don't even want to know there's a virtual machine behind the scenes. You literally need to host a web application, and that's it. That's where App Services comes in. App Services allows you to host logic, host your application code, and get completely out of the management game. Now, the upside to this is you have a tremendous amount of agility, ease of management, because you're not managing anything at all. It's all managed for you. It's just completely lights out as far as what you need to do there. Now, as far as the legacy applications, you can support a lot of legacy applications here, but the more they tie into the operating system, the more changes you'll have to make to support these applications. So you get the least amount of control and the least amount of support for legacy applications, but you trade it all for a lot of ease of management, a lot of agility. So as an architect, you want to be able to select these solutions based upon a business case and business need. Now, as far as Azure Compute, one of the big things a lot of people miss is that while we do have different VM sizes, these sizes aren't just imaginary, they don't mean anything. These sizes actually have consequences and features. So you want to know what the Azure Compute families are. And just like with anything else in Azure, by the time you make a slide on it, it's already outdated. But I want to cover 3 of the big families and let you know 2 new families that are paired. The 3 big families that you're going to want to know for certification are the A family, G family, and D family. The A family is pretty much your value size for VMs. They come in standard or basic. Basic doesn't support auto scale and a lot of the load balancing features. The standard does. That's one of the primary differences between them. So basic is a way for you to save costs if you're never going to replicate across multiple instances, whereas standard gives you the flexibility to do that. In the standard tier, if you go to A8 and A9 VMs, they also support high-performance computing using remote direct memory access. And so this gives you low latency network connectivity to share memory between these machines or emulate the sharing memory. Now, there's A10 and A11 VMs within the A family. These allow you to do high-performance compute because they give you just tremendous amount of compute memory processing power, but they do not support RDMA. So it's a little bit different as far as how you would implement HPC, but it is possible in these VMs. You also have the D family VMs. They're very similar to the A family. The big difference is that you have a local SSD. So your VM is using a local SSD for temp storage, and the CPU is slightly faster. So the D family is if you need the SSD, you need a slightly faster CPU. The G family, sometimes referred to as the Godzilla family, is known for just massive data workloads. So you can go to crazy amount of CPU cores, crazy amounts of RAM, terabytes in a local SSD. If you really need to do computationally heavy data tasks, the G family is really there for you. And it has a later generation Intel processor than the other families. There's also the DV2 families that was just announced at AzureCon. That's a new family that allows you to do a couple interesting things there. And then the N family that gives you GPU support in your virtual machines through NVIDIA GPUs. So the DV2 and the N families may not be discussed as much as in the certification exam because those are a little bit newer in V2, but they're there. I want you to know about them. The A family, D family, and G family are ones you're really going to want to know for as far as the objective domains for the certification exam. Let's talk about cloud services and virtual machines. And this is going to be pretty brief. But the idea with cloud services is that we have roles, and within the roles, we have virtual machines. So in a cloud service, we might have a web role and a worker role. We might have 2 web roles and a worker role. And each of these will have X amount of instances. The web role could have 3 instances, and that's just 3 virtual machines. They're managed by the cloud service. The worker role could have 2 VMs or 3 VMs. The idea here is that these instances are separate from the roles themselves. A lot of people get confused here because they think the roles themselves are instances. So they might say, oh, I need to create 3 web roles because I want to make sure my application is running across 3 VMs. No. You only need to create 1 web role because the web role has a one-to-one relationship with your application logic. So web role, you can think of it as a relationship to a web application. So web role will be your web application. A worker role may be your console application. Now your web application can have 3 VM instances. Your console application got 3 VM instances. That's the easiest way to keep it in check. When you're using virtual machines in a cloud service, it becomes a little bit different. You don't have this whole concept of roles. Even though a lot of people probably remember that when virtual machines first came out, they were called VM roles. Now, a virtual machine will have a single instance in it, and the idea here is that you can have multiple virtual machines in your cloud service. So that you can have many different virtual machines within the same cloud service. All of this is still classic infrastructure. It's not V2 infrastructure. So you want to know how all of this works. And you might get a little confused when you read documentation online because a lot of the Azure.com documentation is switching over to only talking about V2 infrastructure. Let's talk about Azure Compute as far as failover and resiliency. With Azure Compute, we have these things called fault domains and update domains. Fault domains, they represent a group of resources that could fail together. So if you have a single physical rack, that's a single point of failure physically. That's a fault domain. If you have a same server, that's a single physical point of failure. That's a fault domain. So fault domain is really driven by physicality of the servers. Because even though it's a distributed compute, it's the cloud, at the end of the day, there's a server somewhere running your logic. So a fault domain is a physical point of failure. Now, fault domains is all about spreading your logic, spreading your compute, spreading your instances across different fault domains. It would be really bad if you had 3 VM instances of your web application, but they were all running on the same rack, and the power to that rack just died. That would not be good. So that's why we have fault domains. Update domains are slightly different. They're basically a group of resources that are updated together. So the idea here is that when an update comes through, the update domain is all updated together. So the same thing logic applies here. You want to have your compute instances spread across update domains because you really don't want your compute instances all in the same update domain. And yeah, you have 3 instances and you're designed for resiliency, but all 3 go down at the same time. While rare, it's possible. So how do we protect against this? We use a feature called availability sets. Availability sets puts our VMs in separate fault domains and update domains. In order to get the availability set, or in order to get the Azure SLA, we need to make sure we have our VMs and availability sets with at least 2 instances. So, real quick, from a certification point of view, from a logic point of view, if you create a single VM and you host it, and it goes down, you're not going to get the SLA. You're not going to get the 2 nines. It's just not going to happen. Why? It's a single instance. Nobody can guarantee a single instance won't go down. So if you want to meet the Azure SLA, 2 instances and availability set. That's from architectural point of view, from logic point of view, you just want to be absolutely 100% clear of that. You have to use availability set because that tells Azure that these need to be in separate update and fault domains. And you have to have at least 2 instances. So there's something to fail over to if one of your VM instances go down. One of the things I want to talk about is VPN and the different VPN connectivity options in Azure. So we can actually connect an individual machine to a virtual network in Azure using a secure point-to-site connection. It's obviously the best solution if you have, let's say, a remote developer, you want people to be able to connect from anywhere, you have a really small scale deployment, proof of concepts. Point to site is the least friction way to connect to a virtual network and be able to access it as if it's a virtual machine, as if the virtual machine is on premise. However, if you want to connect a whole site, let's say you have a corporate network, you want all machines on the network, or maybe a subset of machines on the network, multiple machines, to be able to access a virtual network in Azure, then point-to-site becomes a little cruddy because you have to install VPN cloud on each machine and make sure it's connected. That's a no-go. So the next option would be site-to-site. Site-to-site is all about making a connection from your corporate network to the virtual network in Azure and allow items on both sites to be able to talk to each other. If you like site-to-site, that's great. However, site-to-site and point-to-site connect over the public internet. What if you need private connectivity? You do not want your requests over public internet. And most importantly, when you're going over public internet, you have to compete with other traffic. ExpressRoute is here for you. ExpressRoute is really all about creating a private connection where you can maximize based upon whatever option you choose with a co-located hosting provider or maybe an ISP. You can maximize performance, minimize any type of discrepancies due to latency. If you just want predictability in your connection, ExpressRoute is ideal here. So the idea is that point-to-site, site-to-site can handle a lot of scenarios, but they're all connections of public internet. If you want a private connection to Azure Data Center, ExpressRoute is the option you want to go with. There are a couple of other Azure services that are covered in this objective. I'm just going to briefly just call out a couple of them that I think that if you haven't touched before, you want to make sure you reach out and touch. Azure Active Directory, really a good identity provider solution that allows you to implement single sign-on for your applications, whether line of business applications, mobile applications, wherever it may be, or software as a service. Maybe you have a corporate Dropbox account and you want everybody to be able to access it using single sign-on. Azure Active Directory as an identity provider also provides a graph API, much like Facebook, that can allow you to query and manage objects within Azure Active Directory directly using API. Traffic Manager allows you to actually control traffic flow to various endpoints. Let's say you have two web apps and they're hosted in two regions, one in East US and West US. You can actually use policies to determine maybe a failover policy or maybe a performance policy, which instance your web apps will be routed to based upon different conditions. The great thing about Traffic Manager, it happens at a routing level. It doesn't actually happen lower than that. It's not a proxy. So once Traffic Manager resolves to a location, so if you're in California, it might resolve to West US instead of East US, then Traffic Manager will let the person who's making a request know, hey, here's the resolution, here's the redirect, and then the local browser may keep that information. It's DNS cached information. So this kind of gives you a big performance benefit where Traffic Manager doesn't have to be hit every single time they make a request to your web application. Azure CDN is a way for you to provide high performance for high bandwidth content. The idea here is that it makes content a little bit closer to the user, so it actually replicates content to data centers that are physically closer to the user than the source of the content so that they can have the highest performance from a bandwidth and download point of view. Service bus is really just communication infrastructure. Whether it's queues, relays, notification hubs, service bus is all about brokering and relaying messages between different application instances. I just called out 4 example services. If you don't know any of them, you're going to want to take some effort and at least look at them from a high level because an objective domain calls these out. So that means these could be used in case studies, these could be used in questions, they could be used as part of your solutions. And you really want to know what different components of your solutions you can use as glue between different application tiers. Let's look at a sample question. With each sample question, I'm going to identify 3 different parts that are going to be useful to you. And these are the same composition you'll see for questions in the Azure certification exam. We're going to start with the business context. You're a consultant connecting a client's infrastructure to Azure in a hybrid manner. Once you get past the business context, the question will generally define a business problem. Your client has identified that they need to connect their own premise network to Azure. They do not wish to install VPN clients on each computer, and they do not wish to place hardware in a co-located data center. Now that we know these parameters, which hybrid connection solution should you select? To answer, select the appropriate option in the answer area. The great thing about certification questions, they tend to give you very specific instructions on what to do. So our instructions tell us that we should select one of these solutions from the answer area. So we have site-to-site, point-to-site, VNet to VNet, and ExpressRoute. Here, a site-to-site connection will make sense. A point-to-site connection will require us to install a VPN client on each machine. ExpressRoute will require us to hook up with our ISP or host hardware and co-located data center. And VNet to VNet doesn't actually serve our business purpose, our business problem here. So now that we talked about infrastructure and networking a bit, let's talk about securing resources in Azure. Here, there's quite a few different ways we want to secure resources, but one of the things we want to focus on here is managed identities. So you can use Azure Active Directory, or you can use Active Directory on-premise. If you use Active Directory on-premise, you'll be using maybe something like LDAP to query, or maybe using some type of application wrapper like a SharePoint site. The idea here is that there's many different ways to connect using AD on-premise. But once you go into Azure Active Directory, you can connect and manage identities in many different ways. So if you want to authenticate somebody, you can authenticate them using many different popular protocols such as SAML, OAuth, OpenID Connect. And if you wanted to have programmatic access to their identity, maybe profile information, directory objects based upon their profile, then you can use the Graph API. The Graph API is a REST API using standard HTTP methods. It allows you CRUD access, create, read, update, delete, and this gives you access to the identity information. Maybe you want to store, retrieve more profile information that comes down with the default claims. The Graph API opens that up for you completely. So now that we've talked about securing resources using managed identities, one of the big things I wanted to go into was data security solutions. So Azure Active Directory is a good way to manage identity, but we still need to secure our data. Now, there's two generally thought of ways when we think about securing data. That's data in transit, data at rest. One of the big things is with data in transit, we want to think about when we're sending data across the wire, how do we protect it? So the most obvious solution is using something like SSL, some type of secure communication protocol. But there are Azure services where we can actually think about data in transit and how we can secure it. For example, let's say we're uploading VHDs to Azure and we want to protect the data. We could actually use BitLocker with the drives. Let's say we want to communicate between two different services. Maybe we want to put a queue between two different services. We can use service buses, storage queues, and use keys to make sure that nobody has access to this other than people with keys. Other services, such as the Azure Import-Export service, they, by their design, when we're shipping drives and things like that, that can protect our data in transit because it's actually not being sent over the public internet. Data in transit is pretty simple, but data at rest can be a little bit different. Now, the idea with data at rest is that we can actually encrypt data at rest using maybe a distributed key. We can encrypt data at rest using some type of logic and application. Maybe we are storing data and we're encrypting it with application logic. But those are the two things you really want to focus on, data in transit and data at rest. And when you design a security solution, you want to make sure your solution covers both. Now, another example I'll give is data in transit and data at rest is covered in SQL Database. With SQL Database, there's a new feature that allows you to encrypt the data stored in SQL Database. But when you make a request for that data, it can actually decrypt it on the fly for you. So the data is encrypted at rest. We talked about securing it from maybe people who are trying to attack our data. People are trying to get after our information, but sometimes we just want to make stuff not available. And it's maybe not as much security as it's an access issue. And one of the features around the new Azure Resource Manager model is role-based access control. So the idea here is that we have roles assigned to Azure Active Directory, users, groups, and services. We can assign these roles a subscription, resource group at a resource level. So we can give somebody access to, at the subscription level, to all resource groups in a subscription, at a resource group level to all resources in that resource group, or we can give them access to a single resource. So we actually go in the portal and say this user will have access to this resource. And it's already predefined different levels of access. So you can actually pick a level. Maybe they're the owner of the resource, or maybe they're a reader of the resource. They can see the resource group but can't change it. They can actually delete the resource group, or maybe they can change things within the resource group but they can't actually delete the resource group. Maybe you want them to be able to add services to the resource group but not touch anything that's existing in the resource group. Role-based access control allows you to get to that minute level of detail. And it's as easy as going into the preview portal and clicking the tab that looks like a key, or not key, a person. And this allows you to specify who has access to this resource group. Traditionally in Azure, if we wanted to give somebody access, we just say, hey, here's co-administrator access to our subscription, and they have the keys to the whole kingdom. As you start to work with external entities, maybe a consulting firm, maybe a third party, you really don't want to give them access to your whole subscription. Maybe you just want to create a resource group and use it as a playground for them to develop their proof of concept or deploy their solution. The idea here is role-based access control allows us to do that. And we can even automate it too with PowerShell, cross-platform, command line interface, and we can even go in and use SDKs available in different languages. The idea here is that it gives us a way to control access to our different resources. So let's look at a sample question. Here, the business context is that you're a developer for Contoso.com. The business problem is that you need to programmatically access and modify directory information for the currently logged in user in Azure Active Directory. You would like to access this information using a REST API. So you need directory information, profile information for the users currently logged in. Which option should you select? This one is not too bad because we know that while we could connect and authenticate people, if we actually want information, directory information about them, we would have to use the Graph API to handle this. OAuth and OpenID Connect allows us to actually authenticate the person, and it can bring some claims back, but if we want to get after the directory information, we would have to use Graph API. Active Directory Federated Services allows us to do some federation if we want to require people to log in and do federation between our own premise identities and Azure Active Directory. So now that we talked about securing our resources, we can talk about our application access and data strategy. One of the big things when talking about application access and data strategy is mobile apps. Now, in the objective domain, this is referred to mobile services, but now mobile services is being phased out for mobile apps, and you have to learn the mobile apps framework. And for a little while, mobile apps wasn't feature compliant with mobile services, but as they add more features, it's becoming one-to-one feature compliant with mobile services. And a lot of SDKs haven't changed. It's not a lot changing as a developer that you need to know other than the name change. But right now, if you go to Azure.com and you look up documentation, you'll see documentation for mobile services and mobile apps. Some of it is even copy and pasted, but they're grouped separately if you're studying for the exam. Now, mobile apps is a pretty cool service. It allows you to build a REST API connected to data sources, whether it's data sources that are managed for you, such as SQL database, or your own logic connecting to storage tables, DocumentDB, HD Insight, on-premise data, Dynamics data, MongoDB, whatever it may be. It also provides authentication, push notification support. Code can be written in .NET using Web API, Node.js using Express, and it's great from a back-end perspective. Even though it's called mobile apps, you can use the mobile app service for anything. I use mobile apps all the time to stand up a REST API when I'm doing a proof of concept for a web application. Maybe I'm building a web application in Angular, and I don't have the time to build the back-end service yet, so I just use it as a proof of concept service building tier. Mobile apps also provides features on the front end where you can add an SDK for iPhone, Android, Windows applications, Universal Windows Platform, Xamarin applications, Apache Cordova. And these SDKs implement features such as automatically connecting to the data, integrating with, these are native SDKs, integrating with authentication, even registering for push notifications and offline sync. So you can implement all this code manually in your front-end application if you're writing Xcode for iOS or you're writing an Android application in Java, or you can use the native SDKs that are available to you. So when you're designing applications using mobile apps, one of the big things you want to think about is offline sync. So when you have a mobile application running on your device, you do have to update the application. So you essentially have to create what's called a sync context. And then when you reference your table, the sync context will actually keep some data offline so that if your device is offline, you still have access to the data. For Windows projects, it's using SQLite most of the time, and other projects is using other data stores. The big thing is that if you want to do this, you actually have to bring in SQLite if you're using a .NET project in Visual Studio. Again, for mobile apps, you can use notification hubs to implement push notifications. So what this does is that the native SDK will actually manage registering the app with the Windows and notification service and configuring mobile apps based upon that. It's going to update the app, so now you're registered for notification. Any server scripts where you want to send notifications, it'll send it to the same hub, and your device will receive that notification. And you can, from server-side scripts, just send notifications. All the devices that has the notification hub configured will receive these. So these devices register with the notification hub. Your server script sends the notifications. You can also optionally send the registration information from your device to your server-side script and have the server-side script manage registering with the notification hub. This one's kind of big, because if you have a scenario where you want to renew registrations, or maybe you need to use server-side information to generate tags, maybe you need to actually query your database to determine what tags are appropriate for them, then you're going to want to do registration on the server side. If not, you can do registration on the client side. One thing to remember, all registrations are transient. So that means they expire after a certain amount of time. If you have registration on the client side, you can update the registration whenever they open the app anew. However, if you have registration on the server side, you have to manage making sure to update it. And on the client side, the difficulty will be, well, if they don't open the app for 3 months, do you just lose your registration, or do you find another way to manage that? Again, on notification hubs, you can use 2 features in notification hubs to change the way you send notifications. One big feature is using tags. Notification hub tags allows you to describe a registrant. So here we can have a notification hub and devices register with that notification hub. Maybe phone devices, tablet devices, and they register with tags. Now from the application backend, we can say, send a notification and use this expression: people who follow the Red Sox or the Cardinals and they live in Boston. And then so one phone device might have follow Red Sox and live in Boston. They'll get the notification. Another one might have follow Yankees, live in New York City, and they won't get the notification. Another device might have follows Cardinals and lives in Boston. Yeah, they're going to get the notification. Whereas another one might follow Red Sox, but they live in Seattle. Nah, they can't get the notification. So this allows you to target a specific set of users based upon tags. So you can start putting information like zip codes, favorites, demographic information about the users. And then from the application backend, you can say, send to this slice of users an appropriately targeted marketing message, or send to this slice of users, maybe you have a weather app and there's a storm coming and you want to send to all the users in localities affected by the storm, watch out, get away from your windows. The idea here is tags allows you to do this. Now, you can send these messages to all these different devices, but if you've ever worked with device messaging before, you probably realize that JSON is the standard for iOS and Android, and XML is the standard for Windows. Now, that's useful, but do you really want from your application backend to send 3 different messages, one for each device type? Of course not. So you can use this feature called templates. Templates allows you to define a message and have it transformed when at the notification hub level into the appropriate format for each different device. So for example, I could send a message called hello, and it's going to use the correct XML for the Windows notification service and the correct JSON for Android and iOS. But that's just one part of the story. You can also use templates to do things like localization. You can use templates to change the structure of the message based upon what type of message you're sending across. Maybe you want a different format of message if it's a different type of message. Templates allows you to just transform these messages at runtime or at the notification hubs level into the right format for each individual receiver. The example we use is just transforming it for each device platform, but you have extensibility to go as far as you want with this. Now, one of the other objectives in this objective domain is to design applications to use a web API. Now, when you design the applications to use a web API, you can design them using a web app, but one of the newer ways to do this is using API apps. Underneath the hood, API apps have a web app associated with them. That's called the API app host. So you can implement a custom API using an API app. Essentially, you can publish this API to external, partner, internal developers. You can have this API essentially have different operations if it's a REST API, and it's showing Swagger syntax or Swagger documentation, then we can actually, the API app would download the Swagger documentation and use that as the API definition. And you can do a lot of really cool things here. Now, the API app can be combined with API management to go another level, but the other objective is not just hosting a web API, but taking any long-running tasks that come in through maybe your web app, maybe the API app, and push it somewhere. And so that's where WebJobs comes in. WebJobs supports a lot of different languages and platforms. Supports Windows command, whether it's a command file, bat, exe, PowerShell, Bash, PHP, Python, Node, or Java. So it supports a lot of different scripting technologies. And you can actually put any long-running tasks off on this web job. And it will actually run these asynchronously and separate from your actual web application instance. When we use a web job, maybe we have an application that generates PDF files from Word documents. So that could be a computationally expensive task. So a web app will just send a request, maybe to a queuing mechanism, and a web job will pick up the messages from the queue and perform them. There's a WebJobs SDK available for .NET so that you can integrate with storage queues, service bus, without having to write a lot of additional code. And then once you have your web job actually sculpted out and you're ready to go, you can run it in 3 different ways. You can run it on demand, as seen in this screenshot, where we're just right-clicking and run. You can run it continuously. The web job is just running infinitely and listening for requests. This is ideal if you have a queue and you want to run a web job based on the queue. Or you can assign the web job to a schedule, where essentially it'll run at different scheduled times. So maybe every other Tuesday, maybe a specific point in time, maybe every night at 3 p.m. So we talked about the data access strategy, whereas designing web APIs, using notification hubs, designing for web jobs. But what if we're in a hybrid scenario? We have on-premise resources, and we want to be able to access them by our compute instances in Azure. So we can connect to the on-premise resources. We can use VPN capabilities. We can use BizTalk hybrid connections. With BizTalk hybrid connections, essentially we're just installing an agent on a local machine that connects out. And then our application connects to this resource as if it's there, right there in our application instance. So from our application code, we don't have to do anything new. From the web app instance, all we have to do is say, hey, there's a hybrid connection. We'll connect to that and install the hybrid connection manager on a VM with the data we want to access. So a really good example of hybrid connection is SQL database. We have a SQL database on-prem and a web app in Azure. We don't want to expose everything on-prem, so what do? Install hybrid connection manager on the same VM as the SQL database, configure it so it gives access to the SQL database. In our web app, go in the portal, say, new hybrid connection to that SQL database VM, and that's it. Our web app uses this regular SQL connection string, doesn't know any difference. If you want to go a little bit more elegant with it, you can definitely use Service Bus and actually set up complex relays, queuing systems, and go far more elegant. So hybrid connections is really good if you want to minimize any changes to existing application. If you're doing greenfield or you're just going in and you want to re-engineer everything, then Service Bus is kind of what you see a lot of people going with. Now, if you do decide to use VPN, there are some constraints. For example, if you want to use ExpressRoute, you have to use the ISP that supports it. If you want to use point to site, you have to install a VPN client on every device. So same scenario, SQL database. If you want to use point to site, you would have to install a VPN client on that VM with SQL database and make a singular connection from that VM to the Azure Virtual Network, and then make a connection from the web app to the Azure Virtual Network, which, hint, is also a point to site connection. Or you can do site to site, where the VMs within whatever scope or whatever virtual network you have on premise will all connect to the virtual network in Azure, and you have that easy connectivity. Still, the web app, when it connects to your virtual network, will be done over a point-to-site connection. So you have a lot of options here for hybrid data access strategies for web applications in Azure. Designing a media solution is one of the other objectives. I'm not going to spend a lot of time on this, but essentially it's just all about building up a media solution using media services. Media services is a combination of quite a few different services. It's all about just building like really scalable media management delivery solutions, where it includes uploading videos, encoding videos, driving data from those videos, mining data from those videos, packaging them both pre-packaged, just-in-time packaging, on-demand video streaming, live streaming, allowing you to look into live streams, so many different features. And the great thing about media services is a lot of this is out of the box when you use media services, but if you want to really go down to the rabbit hole, you can actually develop your own custom workflows and go well beyond what's provided out of the box. So let's look at another sample question. Here you're an integration developer for Blue Yonder Airlines. That's your context. Blue Yonder has deployed their latest web application to Azure App Service. You are tasked with integrating that new web app with a legacy WCF service that must remain on-premise. Blue Yonder wishes to do this without opening any new inbound ports on their corporate firewall. So your goal here is, which solution should you select? So you got to select the appropriate option in the answer area. So we want to integrate with a legacy WCF service, but we can't open any new ports. So that cuts out what? API app, API management. I don't even know what WebJobs is doing in this list. So it's really easy. We'll just isolate this down to service bus because we can use a relay and we're pretty good there. Now that we talked about some of the other solutions, let's talk about how we could design an advanced application in Azure. Now, advanced applications cover a large scope in this objective. And so one of the things as a developer or architect you may have never touched, or even IT pros moving into architect, you may have never touched is HPC. However, HPC is called out in this objective. So I just want to take a brief moment to talk to you about HPC options in Azure. So you can use the Azure Batch service, which is basically HPC as a service, or you can use some of the existing HPC tools. Specifically, I want to call out HPC Pack. Now, HPC Pack uses RDMA to implement high-performance computing between virtual machines. If you're not familiar, RDMA, or Remote Direct Memory Access, is a hardware-level implementation. It kind of behaves like another NIC, a network interface card. And essentially, the RDMA connections are much lower latency than traditional network connections, and they basically skip past all of the other network tiers when you're making a traditional network communication request. And so very low latency, and to the applications, it may seem like they're sharing memory. At the end of the day, it's still a networking option, but it's a little bit interesting implementation. So you can only do these with A8 or A9 VMs, and you can definitely use this to implement an HPC scenario. You can do this with virtual machines. You can do this with worker roles. There are some HPC services where you can actually do this using Windows VMs, Linux VMs, a lot of scenarios here. When you're doing HPC rollout in Azure, you can do it in 3 different ways. And it's not, all-inclusive list, but you can do a parametric sweep, do everything in Azure exclusively, basically stand up your whole HPC infrastructure in Azure. Or the one that I want to really call out here is a hybrid solution with on-premise. So let's say you have an HPC rollout on-premise using HPC Pack, excuse me, and you have HPC Pack, your VM's on-premise, you're running a high-performance compute job. Maybe you're trying to crunch some numbers for researchers. And your existing infrastructure can't support the type of tasks you need to do at a time that's reasonable for your researchers. By the time they get this information, it'll be useless. So you can burst to Azure. What this means is you can stand up VMs, or I've seen this done with worker roles before, and essentially you create them temporarily to just offset some of the workload. So spread the workload around on these VMs in Azure, along with whatever infrastructure you're using, get the computational tasks done, and then spin them down. So it's a burst to Azure because it's temporary. Again, another way you can do high-performance computing using Azure. Now, for long-running applications, essentially, we talked about web jobs, so the only thing I wanted to call out here is worker roles. Worker roles are really good for long-running perpetual asynchronous tasks where you don't need any user interaction or input. Input may come in from well, it's not really input. The way they receive data is they poll or receive it via some type of asynchronous endpoint. But the idea here for worker roles is that they could test the queue, they can use any other type of communication mechanism to determine if there's any work for them to do. And they're just long running, and they're asynchronous by their design and nature. Your web role gets out of the business of doing long running compute, and it sends it off to worker roles who can do this. So this allows you to design stateless components. You can route requests to your web roles. It makes things really simple and really easy to follow. And worker roles, web jobs can both do this. Big difference between worker roles and web jobs. On the web job side, they support a lot of different languages, a lot of different options there, a lot of scripts. You can do a lot of things there on web jobs. Worker roles, they're just VMs, so you can install almost anything on them. If there's something you need to install, like a GDI plus component that does PDF generation, you can do that. Web jobs support some subset of GDI functionality, but it's not. You can't install anything on a web job like you can on a worker role. So those are the things you need to take into consideration as an architect when you're trying to decide between these two options. When you're talking about storage, you want to think about selecting appropriate storage options for your scenarios. You want to consider performance. If you're doing development, you might want to consider queue-centric pattern. And then when you're using VMs or cloud services, you want to think about how they interact with storage services or external resources such as SQL database. So for example, VMs interacting with storage service. If your application logic is accessing storage, where is the storage for the actual VHDs going to live? If your VM's interacting with SQL database, is it Azure SQL database? Is it SQL database on SQL Server, standalone, hosted on an Azure virtual machine? What ports do you need to open? There's a lot of things you need to consider here. I want to talk to you about a couple things with storage options, and the first one is the queue-centric pattern. The competing consumers pattern, this is available in MSDN and a cloud patterns guidance, is a very general pattern talking about how we can asynchronously separate long-running compute tasks from our application front ends, whether they're a web front end, desktop front end, mobile device, IoT device, whatever. So these application instances are generators. They generate messages. So let's use the example of we're a website and we're hosting images and we need to create thumbnails whenever somebody uploads an image. So user A goes to our website, uploads an image of maybe their vacation, and we need to generate a thumbnail. Well, we don't want the web application to do that because the web application needs to receive this image and move on to another user. So we put this image maybe into storage. So a storage blob, we put this image in there. Now we put a message on a queue, whether it's service bus, storage queue, that's really up to you as designer of the application. And we say, all right, somebody else is going to create the thumbnail. Web application, move on to the next user. So web application minimizes the amount of overhead involved with long-running tasks, frees up a lot of threads, make everybody happy. Now this queue has all these requests to generate thumbnails. When we say competing consumers, from a diagram perspective, the consumers is referring to a pool of instances that actually pull messages from those queues and does some logic based upon it. So it might pull a message from the queue and generate a thumbnail. It might pull another message from the queue and generate a thumbnail. If an instance goes down, another instance will spin up and generate them. If it's a priority to generate these thumbnails quickly, we'll create more consumer instances. If we're the type of company we say, look, if it takes 15 minutes to generate thumbnails, fine, we might just spin up 1 or 2 consumer instances and say that's good enough. If we ever have a promotion where we know a lot of people are going to be uploading images, we might go up to 15 consumer instances. So it seems really fast for the new users coming in. They're like, oh yeah, this is wonderful, wonderful, great. That's a competing consumers pattern. We can scale up and down on both ends, and they're asynchronous, so they don't affect the other. We can scale up the web app to handle more users who are viewing images but not uploading, and scale down the consumer side, or we can scale up the consumer side and scale down the generator side if less people are visiting the website looking at images, but a lot of people are uploading images. Maybe we have a promotion where if you upload an image and we select your image, you'll win a trip to Paris. And then all of a sudden, not a lot of people are looking at images, but everyone's uploading them. So we get to scale them separately. That's the big thing about the competing consumers pattern. We get that option. It's not something if they were all locked together in a single application we could do. Another pattern I want to talk to you about is the Valet Key Pattern. This one's a little bit simpler. I know I say a little bit simpler, but the diagram looks more complex. But this one's in 4 pieces. So the idea here is that whenever a user requests a resource, we actually go to a storage account, go download that resource, validate the user, and then return the downloaded resource as a string to the user. You've probably seen a lot of applications that do this. However, this is wonderfully inefficient because if you've ever had a parent who you said, hey mom or dad, can I get a cookie? And they say, oh yeah. All right, well, are you going to get the cookie for me? No, you can go get your own cookie. Well, that's what the Valet Key Pattern is go get your own cookie, but for applications. So the idea here is for the Valet Key Pattern is we as a user go and request a resource. The application validates our request that we can access the resource. That's the parent checking whether or not we can have a cookie or not. Maybe we've had too many, maybe we haven't had one yet, maybe we ate dinner, maybe we haven't eaten dinner yet. They're validating our request. If our request is valid, they'll go and give us an access key that gives us the right to get that resource. So they'll return the access key to us. And then we as a user will go get that resource on our own. So in the context of a web application, the user will say, I need to download the image of a bridge in Texas. And we'll validate that the user has the right to download that image. So we might validate them against authorization logic, business logic, whatever it may be. And our application will go to the storage account and get a SAS token so that they can download that image. Then the application returns that SAS token to whatever web front-end application they're using. And then from the web browser point of view, maybe we'll do a 301 redirect. Maybe we'll do some other type of logic, something in JavaScript. But essentially, we're letting the browser go and download the image. So our application, as soon as it gives the token, it's completely out of the business of managing this request anymore. The users download the image themselves. That saves down on bandwidth, that saves on overhead, saves on a lot of things. Both the competing consumers pattern and the Valet Key Pattern are available on the MSDN Cloud Patterns guidance site. Let's talk about integrating other Azure services in our solution. This is again listed in our objective domain, and it's really, we have a couple of these in the architecture exam, and it's all about just saying, hey, look, you have to use a lot of different Azure services to compose a solution. So be aware of all of them. You don't have to be deep on each of them, but just be aware of what they are. So in this example is 4 services. Machine learning allow us to actually do predictive analytics based upon a set of data. Big data, basically understanding what HD Insight is in the context of Azure. How we can set up clusters, whether they're Hadoop, whether they're Storm or Spark, set them up in Azure, analyze, ingest, process, store data. Media services, which we talked about earlier, just all-inclusive solution for streaming, encoding, doing analysis on data, storing data, securing it dynamically or statically packaging it. And Azure Search, which is really about providing a search engine over top of a set of data. If you don't want to implement your own search engine, you can use Azure Search as your search engine, ingesting whatever existing data you have. So let's look at another sample question. Here the context is that you're an operations engineer for Parnell Aerospace. Your department is using high-performance compute and RDMA to run its most computationally expensive programs for the staff researchers. You have been tasked with selecting appropriate virtual machine sizes for the infrastructure in Azure. So which sizes could you select to support your requirements? To answer, select the appropriate 2 options in the answer area. So I can tell you right away, the A11 is not an option. It supports high-performance compute, but it does not support RDMA. And D2 is not an option because it supports neither. So we know A8 and A9 supports RDMA. But I did want to add this question because the new N-tier VMs support RDMA too. That's the NVIDIA-driven GPU series of virtual machines. They also support RDMA, so they can support computationally intensive tasks. In this next objective, we're going to talk about web apps and how we could design them in our architected Azure solutions. These next couple sections are a little bit briefer than others because they have a smaller percentage. And it's because there's less of a delta between what you might know today and what you need to know for the certification exam. From a web app point of view, there's many different ways we can store web apps. We can store them, or web applications, we can store them in Azure App Service as a web app. Instant deployment, we can do SSL, custom domain names, all its configuration settings. We don't have to do a lot of heavy lifting here. We can use WebJots for background processing. We can scale to larger machines. We don't have to redeploy things to scale. It's really useful for us. Web apps is a very low friction lease management solution. From a virtual machines point of view, we can set virtual machines into using load balancers so that we can have resiliency across different VM instances. If they're in availability set, we can actually go and make sure that they're load balanced too, so that if there's an update or a fault, they'll fail over to the other virtual machine instances as opposed to our application failing outright. From a cloud services point of view, we still get that load balancer, but we don't have to actually go configure it like with virtual machines. And we still get background processing with worker roles. We still get front-end logic like with web apps, with web roles. It's just a little bit more management on the cloud services side. From a deployment of web apps point of view, the big thing you want to know is they can deploy whether you're in continuous delivery with Visual Studio Online, GitHub, Mercurial, Bitbucket. You can use whatever version control you want on those for that. You can even remotely do continuous deployment from an external repo if you like. You can deploy using web deploy, either directly using PowerShell, grabbing a web deploy package from IIS instance and doing web deploy deployment, or from Visual Studio, whereas if you right click and deploy to a web app, behind the scenes it's doing web deploy for you. You can do an FTP deployment, which is exactly what it says, deploy files via FTP. And then you can deploy directly to your production slot, or you can create additional slots in your app service, web app, API app, mobile app, logic app, or not logic app, API app or mobile app, because both of those are backed by a web app. The idea here is that you can create a development, QA, testing slot, and do your continuous delivery to those slots. Allow people to validate that the application works in those slots, and then swap the slots and allow people to switch the code to production, switch your earlier production to that whatever that previous slot or the source slot was. That way you can test the application out, validate it works, and then send it to production. As far as business continuity and web apps, a couple things we can do. We can scale up and out. Essentially, from a web apps point of view, we can create more instances. We can change the size of instances. From a SQL database point of view, we can switch tiers and levels. We can use features such as elastic scale. Azure SQL Database has high availability pretty much built in. From a disaster recovery point of view, Azure SQL Database allows us to do a couple interesting things. We can actually have a secondary region with read access to that secondary region if we want, in case there's a data outage in primary region. We can replicate across these regions. The idea here is that there's a lot of HA options built into SQL Database web apps. Usually by the time you get to architecture tier, you know a little bit about them. So as far as this exam is concerned, you really want to think about them as bricks, and you want to connect these bricks together and lay these bricks together to compose a formal solution. So instead of thinking about app service continuity, VM continuity, and SQL database continuity as different siphons, you want to think about how you will compose these together to build a full solution. A really good example I always give is if you look online, you'll see on Azure.com, MSD, and documentations examples of deploying SharePoint architecture to Azure. SharePoint is a really good example because it composes a lot of different tiers. A database tiers with VMs and SQL database, a web front-end tier, application logic tier, and then you will also deploy an AD box for that tier. And so you have to design for high availability business continuity by default. You don't want any of these tiers to have a single VM. So you're now thinking about availability sets for each tier, multiple VMs for each tier. SharePoint kind of forces you to think about business continuity for your web solutions. So let's look at a sample question for this section. The context for this question is that you're a developer for Fabricum.net. Your production web application is hosted in Azure App Service using a web app instance. You need to host the latest versions of the application for your Q&A and test teams without affecting the latest production deployment. So which web app feature would you use? So we're only selecting the single option. We want to make sure that we have a different instance of a web app for our QA team, for our test team, but we don't want to affect the production instance. So almost immediately based upon what I said earlier, you're going to go to deployment slots. This allows us to basically create other web apps that are related, but they're essentially separate enough that we can deploy to these deployment slots without affecting the production application. Now we're going to talk about the last section, which is designing a management, monitoring, and business continuity strategy. There's a couple things I want to cover here. The big one is about hybrid architectures. Virtual machines compute on-premise, virtual machines compute in Azure. There's a lot of things that have to be shared. Virtualization, management, development, data platform, identity. All of this has to be shared across these different scenarios. And so we have stuff on-premise, stuff in Azure. How do we manage this? Well, System Center allows us to manage these resources. And System Center is composed of many different parts. We have the configuration manager, which is really just about configuring applications, client devices. It's configuration. We have operations manager, which is really our monitoring tool. It allows us to set up alerts to let us know when things get outside of predetermined thresholds, monitor solutions from a forest from the trees perspective across a whole hybrid deployment, not just in Azure, not just on-premise. We have a virtual machine manager if you want to actually manage your data center and actually manage the VMs in your data center. There's others, DPM, orchestrator, all of this is available in System Center. So System Center is really good for hybrid scenarios, whether you're doing a private cloud, whether you're using a public cloud such as Azure, or using a cloud as a service provider or co-located facility. The idea here is that System Center will allow you to see all of your resources at a much higher level than each of these individual providers. So when we think about monitoring, we want to come up with a strategy for monitoring. So a lot of these services we use, like cloud services, web and worker roles, app services, web apps, they already have built-in diagnostic capabilities. They have charts, diagrams, logging. We can throw all this stuff into storage. So they have built-in capabilities. And we can enhance this with System Center. So System Center has management packs for SQL, actual SQL Server standalone, Azure SQL database, and Azure Compute itself. So we can use these management packs to extend the built-in abilities to give us more information. We can bring in open source tools from third parties, or we could bring in other tools such as Application Insights for Visual Studio Online, New Relics for telemetry, Operations Manager from the System Center point of view. And then we can use this in a scenario where we can extend and basically, almost like a plug-in model, we're going to enhance what we're monitoring. Monitor more, get more information. So monitoring, you have to come up with a strategy for it. And that's what this objective is really all about, is saying, hey, know all the different components of monitoring so that if we say we need to monitor for X or we need to monitor for Y, you can say, hey, we would use this component, or hey, we would use that component. That's what really design a monitoring strategy is all about, is the objective. Disaster recovery strategies is pretty similar. You need to know what options you have for DR. Once you know what options you have for DR, it's easier to design strategies because you can pick the appropriate option. So whether you use a Hyper-V recovery manager to recover Azure deployment to on-premise or on-premise deployment to Azure, whether you use a Microsoft Azure backup, which integrates with Windows Server backup, what if you're doing a recovery strategy using Store Simple? I know a lot of people see Store Simple as a way to make data access cheaper, easier to manage, but it's also a DR strategy. If you have data that's being replicated to the cloud, it's now available if something happens with your storage on-premise. Of course, over top of all of this, you have simple backup solutions, but then you also have System Center DPM, which is really just about, backed up data stored in Azure, whether it's, physical VM or Azure VM. DPM is kind of like a superset of as far as what it can provide, and superset of features that each of these individual services would provide on their own. So a lot of different options here. Hyper-V Recovery Manager is really about orchestration recovery. Azure Backup is literally just backup. Store Simple is about your actual files, your files data, this on local SAN and you want to push to Azure storage. DPM is just a level of abstraction above all of that. So let's look at another sample question. Here, you're an operations manager at Woodgrove Bank. You need to monitor your infrastructure deployed in Azure using System Center and configure alerts when any virtual machines are in an errant state or their properties are beyond pre-configured thresholds. You probably already heard me say that phrase, so you already know the answer. Which System Center feature should you select? To answer, select the appropriate option, singular, in the answer area. And that's going to be operations manager, because you probably heard me say pre-configured thresholds already. So that ring operations manager, because we're monitoring, we're setting alerts. So let's talk about some of the study resources that can help you with this exam. On Azure.com, there are learning plans that are available that gives you a visual depiction of what you need to do to master a certain topic area. So it's a collection of articles, demos, tutorials that you can walk through to achieve a much higher level of understanding for a service. Even if you think you know a service, I would recommend looking at the learning plan for that service. And from our Azure architecture exam point of view, the big thing you want to think about here is knowing these services well enough that you can always identify the right one based upon your business context scenario. So that's virtual machines, site recovery, Azure Active Directory, Azure Automation, and SQL Database are all featured learning plans on Azure.com. So I would recommend that you walk through each of these learning plans. You might notice one there sounds a little off, Azure Automation. Now with Azure Automation, even though it's not really caught up that much in this exam, it's more related to the IT Pro exam, Azure Automation Learning Path does cover some of the things you can do in PowerShell as far as automating management of your services. And these are things you're going to want to know as an architect to know what options you have from an automation perspective available to you when you're architecting these solutions. Because you do have to deploy these solutions as your architect, and that's one of the things you do want to know for this certification exam. Microsoft Virtual Academy does provide some incredible resources for you to help study for this exam. There's an Architecting Microsoft Azure Solutions MVA session that covers this exam specifically. There's also, and this is one of my personal favorites, Azure Solution Training. It's training for sales professionals, but sales professionals tend to think of things as forest from the trees. So we're looking at the services as blocks and telling them what services does what so that you can propose solutions to clients. Fortunately, as an architect, you're doing the same thing. So why not take the sales training? Sit through there, look at a high level what each service does, because you need to compose solutions. You notice a lot of objectives about composing strategies and solutions based upon different services. There's also an Azure IaaS Deep Dive Jumpstart that goes a lot deeper than the 533 certification exam that I recommend, because it covers a lot of architectural concepts. And from a developer and data perspective, there's Polyglot Persistence. That's an MVA session that covers combining different data services for really unique and useful scenarios, which you couldn't handle with just a single data service, or at least couldn't handle effectively. So these are the MVA sessions I recommend. As far as other resources, there's a Microsoft official courseware for the other certification exams, but not for 534. 20532 and 20533 have Microsoft official courseware. For 534, there's an edX course called Architecting Microsoft Azure Solutions that's available to you. So I always recommend, if you're going to take this whole certification path, to just take all of the mock that's available, or Microsoft official courseware that's available, and combine it with the edX courses. There's a Microsoft Pressbook to help you study for this exam, and there's Microsoft official practice tests for each of these exams. On top of all of that, you have Born to Learn that has forums and exam prep wiki to help you prepare with other MCPs who would like to earn the MCSD and Azure architecture. So in review, we cover quite a lot in this session. We talked about infrastructure networking, security, storage data access, advanced applications, web apps, and business continuity. Hopefully this session helped you prepare for the architecture exam, and I look forward to seeing you as a certified Azure Solutions Architect, and you can help me build out some of my solutions. Thank you.